Hello everyone, welcome to project number 11, and in this project you'll be implementing a engine using Clickstream data. So I hope you already know what a recommendation engine is, but of course let me give you a high level overview how a recommendation engine works. In most of the cases the recommendation engines would use machine learning models, but there are scenarios and there can be scenarios actually when rule based recommendation engine can also be used. By the way, what is recommendation engine? We'll get the answer if you ask this question. What happens when you watch same type of videos in YouTube or OTT platforms? For example, you are watching YouTube and you are watching only car related videos. For example, I am watching videos with BMW cars, Tata cars, Audi cars, Mercedes cars, etc. So if you keep on running this and if you keep on watching videos that are related to cars, these data would be captured by recommendation engine, and then in your home screen you'll see only car related videos. And this recommendation engine can be based on machine learning models or rule based also. Now this is what a recommendation engine is. Of course there can be various types of videos that you can watch, and a recommendation engine would work on all those different types of videos that you watch, and depending on that your home screen would be populated with only the videos that you typically watch. And if you get a video, let's say, or a channel which you are not interested in, you can say that I'm not interested in this video or do not recommend channel, then YouTube will not recommend any channel as such. So for all these behind the scenes recommendation engines work. As I said, recommendation engines can be implemented using machine learning model, or it can be implemented using rule based logic also. In our case it will be rule based logic only. So how the recommendation engine would work in our case, as we are going to implement a rule based recommendation engine, how we are going to implement it? First of all the user activities are captured using something called clickstream data. So what is the clickstream data? Whenever we make any clicks, whenever we go to a particular page, its URLs, its metadata, the button that we click, the video watch duration, and all those things are captured, which are called clickstream data. And those data are sent to a centralized server and then analyzed. So this is how clickstream data is. And you can imagine for platforms like Netflix, Amazon Prime, YouTube, Hotstar, Geo Cinema, etc., there can be terabytes of data per day which are getting captured. And those data sent to a centralized server, and almost near real-time analytics and historical analytics are done using those data. So the clickstream data that is captured using clickstream tools like Google Analytics, Adobe Analytics, etc., the data is sent to a Kafka topic, and from there it would be read and processed by PySpark or Spark Streaming. Not only that, the Spark application will also get data or static data from various different other static sources also. For example, content data, customer data, user data, etc. And from there, using all these, the PySpark recommendation engine can create near real-time recommendation engine or historical recommendation engine. So an example of historical recommendation engine when you use online retail platform. For example, you have been buying, let's say, multiple books from O'Reilly for over a period of time. So let's say all the books are for data engineering only, and machine learning, let's say. Now in that case, based on your buying habits, the online retail website will recommend you that you might be interested in certain types of books. So that is done using historical recommendation engine also. And in our case, this is what we are going to do. We'll be implementing a rule-based recommendation engine using clickstream data. The static data would be user data, content data, and a little bit more. And then we'll get clickstream data in JSON format, which will be in Kafka topic, and that would be read by PySpark. And the recommendations that are going to be generated would be shown in the OTT website, and it would be stored in data warehouse also. Now, of course, you do not have to send the data to OTT website. You can show it in a console or you can store it in a database also. But this is how our recommendation engine would work, or the engine in the project would work. As I told you that we are going to implement only rule-based recommendation engine, not using machine learning model. So in that case, there would be various rules for real-time and historical recommendation engine. First would be the real-time engine. So you see here, there are four types of recommendations that I'm asking you to generate. First is the personalized recommendation, and it has to be near real time. So when I say near real time, it can be a few minutes to a few hours also. So in real-time recommendation, it should be based on users browsing, playing video or watching, internal link redirection, searching, downloading contents, etc. So the recommendation should be based on all these activities. And these data are captured using the Clickstream tools. As I said, the Clickstream tool can be Google Analytics, Adobe Analytics, or anything of that sort. So the browsing and watching data, etc., can be filtered using click type column. In the next slide, I have given the column description also, and the personalized recommendation should be based on last 8 hours history of every user. Remember that. Understand what the problem statement is and then only try to implement it. And even before understanding the problem statement, you will have to explore the datasets or explore the data that I'm going to give you. Then the next would be generic recommendation, in which case the homepage should show top 5 most popular TV shows for a particular country on a specific day based on the previous day's watch, browse, and search patterns. So these are the three different patterns. Based on these three patterns, the top 5 most popular TV shows should be shown in the homepage. Of course, in this case, you will not be sending any data to homepage. Either you can save it in a database or you can show it in the console. I would recommend you that you do both. You save it in the database and show it in the console also. And it should be shown for all the users of that country. Now, this is the reason this is a generic recommendation. So if you have opened Netflix or Amazon Prime ever, it will show you what is currently trending in your country. So I'm from India. If I open Netflix, it'll show me that the top trending videos or top trending TV shows or movies or documentaries, etc., that are trending in India. So that is a generic recommendation, and it would be same for all the users who are in India. Similarly, there is one more generic recommendation wherein the homepage should show top 5 most popular movies of individual genres. I'm not sure whether it is pronounced as genres or genres, but anyway, you have to find out or you have to analyze the top 5 most popular movies of individual genres for all users of a specific country on a specific day based on previous day's watch, browse, and search pattern. It is similar to the second bullet point or the second problem statement. The difference is that here we have popular TV shows, but here we have popular movies, and popular movies for individual genres, and it should be shown for all the users of that country. Now the final one would be personalized because you watched recommendation. It would be typically historical analysis or near real time also based on the user's watch history. This should be shown in user's homepage. So the rule should consider the click type and the page URL for the personalized because you watched recommendation. So what are these columns? Click type and page URL. This is mentioned in the next slide, column description. So these are the various values that a click type can have. We can have add to cart, rent, checkout, browse, search, internal link, etc. Now why it is named as click type? Because whenever there's a button, let's say, using which you are adding a product to a cart or renting out a movie or something, or you are searching something, you are going to an internal link, going to an external link, etc., all those button clicks would be captured in the click type column. And along with the click type, there would be page URLs. What would be the various page URLs? For click type browse, these are the different types of page URLs you see. In case of browse, whenever the click type is browse, you'll see that the page URL contains genre and the movie type or the TV show type, etc. Of course, I have not given extensive data wherein typically you'll have the content ID also, the content metadata also. I have not given you all those details, but if you can implement these things, those further details using metadata, using content ID, using content type, etc., can be implemented as well. Then the next one is for click type play, pause, or stop, and the page URLs can be this. And all of them belong to the watch category, right? All of them belong to the watch URL. There's drama, comedy, thriller, documentary, sci-fi, etc. For search, these are the various click types. For download, these are the various page URLs. For internal link, these are the various page URLs. And these are the various search keywords that you'll find in your dataset only when the click type is search. And these are the different values that you can have based on the dataset that I have prepared. So you have to use all these collectively to implement the real-time recommendation rules. Actually, this is not a real-time recommendation rule. This is near real-time, you might say, or hourly or daily recommendation rule. It's not real-time actually. Let's talk about the datasets now. And as I already told you that you should explore the data, open the datasets. Each of the different types of datasets should be explored by you. What type of data is there and what data would be useful for you. I've given you 17 files. The total size is 13 GB, which is uncompressed. And we have this OTT cast data.json, which contains the cast of the TV shows or the movies. Then Clickstream data, there are 14 files of Clickstream data, and it contains records of 2026. So from 1st January 2026 to 31st December 2026. Then you have OTT TV show data, OTT user data, OTT content data. The content data is a little different than the typical CSV files that you would see. It's slightly more complicated, not too much, but a little bit more complicated because I wanted you to practice the other things also in Spark. There are various functions available, so you'll have to use those functions. Now, why am I showing you only OTT content data.csv? Because you see here the date or content added date in OTT has a different format like September 24, 2021. In some cases, like TV show, the duration says, content duration says 2 seasons, but for movie, it says 91 minute. So again, 2 seasons and 91 minutes. We'll have to separate these two out. Then we have the content genre or genre. The content genre also has multiple values. For this TV show, the genre is multiple: international TV show, TV dramas, and TV mysteries. For movie, we have two different genres: children and family movies. So you have to separate this out. In this file, a single column has multiple values. So I'll have to find out a way how to separate them out. This is the content data CSV. Similarly, we have content cast JSON file also. So you have the content ID and the content cast, and the cast is an array. So this is an array and only the content ID. Of course, you can use this content ID to match with content data and find out which TV show has which cast, which movie has which cast, etc. So this is in JSON and this is an array. I think you know what has to be done here. For hand, let me tell you that you'll have to flatten it. All right, now after that, you have to implement these historical recommendations also. Now, if you look at the architecture of the recommendation engine, you see that after doing the analysis, you have to store it in data warehouse and you have to send it to a website. So these are the two output targets that you have to send the data after doing processing or after doing analysis. For OTT website, definitely you'll have to do the analysis in PySpark. But for data warehouse, you can just get the clickstream data and save it as is after flattening the data to the data warehouse, and then you can run historical analysis. So for website, you have to do the analysis in near real time. So you get the data, do the processing, and then show it in the website. In case of you, when you do the implementation, either you have to save it in a database or show it in the console. And I would recommend that you do both. Save it in the database also and show it in the console also. For historical analysis, you have to get all the records and store it in data warehouse. So you store it as a raw data, and then whenever you are planning to implement these historical recommendations, just look at how those data has to be processed and how the recommendations can be generated along with reports. So it says that the analysis must be done once a month with report generation. So there are two types of analysis. The first one is content analysis, and the second one is customer experience analysis. So you have to implement all these 11 use cases or business statements using the data that I have provided you. So that's all about this project. Please go ahead and implement it and use the datasets that I have given.